Passing variables into methods by value can sometimes, however, be confusing. And that's because when you call a method and you pass an object as the parameter, rather than a primitive data type like we've been looking at, then it's the variable that contains the reference to the object, that is, it's the pointer which is copied across. To state this more fully, when an object is passed into a method as a parameter, a copy of the variable on the stack containing the reference to the object is what is passed, and it's this variable on the stack that is passed by value. This means that a copy of the pointer to the object is created. The object itself is not copied, and in fact it's not the object that's passed into the method, but rather a pointer to the object. For example, if we pass a copy of a list into a method, then the parameter value will be a copy of the myList variable, which is a pointer to the object on the heap. So I hope that's clear. Many programmers misinterpret this as objects are passed by reference, but they're not. It's the pointers to the objects that are passed by value. Let's look at an example of why this is significant. On screen here now, I've got some code which creates a customer and then calls a method which changes the customer's name and prints out the customer's name at the end. Assume that the customer class has been well written and it has a get and set method which do exactly what you would expect. Well, what would the output to this be? I suggest you pause the video and work through this example using the stack and heap pictures that I've been showing you to try and work out what would happen. And when you've had a think about it, press resume on the video and we'll talk it through. So let's talk through this example. First of all, we have a line that creates the new customer object. The constructor of the customer takes a string. So the first thing that happens is that a string will be created on the heap. Then the customer will be created with a property that references the string object. And then a variable will be created on the stack pointing to the customer object. When we call rename customer, because we pass a reference to the customer by value, a new variable will be created on the stack called cust, which will be given a copy of the pointer to the customer object on the heap. Now we change the name of the customer. Now I hope you remember that strings in Java are immutable. That is, you can't change the value of a string. If you do this, what happens is you actually create a new string object. So when this line of code runs, what happens is that a new string object is created on the heap, and Java changes the pointer within the customer object to point from the original string object to the new string object. The original string object is no longer referenced now from anywhere, and so the memory that it is taking up can be freed for other objects to use. That process is called garbage collection, and we will be talking about that in a few videos' time. Finally, we exit the rename customer method and we go to the print line. And now our C variable, which is back in scope, is referencing the amended object customer, which has a name pointing to the new string Diane. So the output from this line of code should be the name Diane. I hope you were able to predict this outcome. If you were, then well done, as it means that you now do understand the mechanism of how variables are passed between methods.